Hey everyone, ready for a deep dive? This time we're tackling a topic that's both universally felt and scientifically fascinating. Love.
Definitely fascinating, and way more complicated than a love song would have you believe.
You got that right. For this deep dive, we're going deep into two articles. Love, Actually, from Science in the News, and the neuroendocrinology of love, which is a mouthful I know from the Indian Journal of Endocrinology and Metabolism. And one thing they both agree on is that love, well, it's not just one thing, is it?
Nope, definitely not. It's more helpful to think of it in stages, like a three-act play. Lust, attraction, and attachment, each distinct but interconnected.
Okay, love that analogy.
Yeah.
So Act 1, lust, that initial spark, the I want you now feeling. What's the science behind that?
Act 1 is all about setting the stage, and the main players. Testosterone and estrogen. We often think of them as male and female hormones, but they both play crucial roles in both sexes, especially when it comes to lust.
So it's not just about feeling attracted to someone, it's that primal urge to, well, make sure the species continues, right?
Exactly. Reproduction is definitely a factor. It's fascinating how research points to testosterone as a major player in boosting libido in everyone. That initial pull, that drive for sexual gratification, that's testosterone at work.
Okay, so that's the initial spark.
Yeah.
But then we move to Act 2, right?
Yeah.
That candy, can't sleep, butterflies in your stomach kind of love. That's attraction taking center stage.
You got it. And this is where things get really interesting, chemically speaking. We're talking a whole new cast of characters. Dopamine, norepinephrine, and serotonin.
Dopamine, that's the reward chemical, right? The one that makes us feel good. I'm already seeing a connection here.
Spot on. It's released when we do things that make us feel good, and surprise, surprise, spending time with someone you're attracted to. Total dopamine rush. Your brain basically gives you a gold star for being around them.
So it's not just in our heads. It's our brain chemistry literally rewarding us for being close to someone we're into.
Wow. But dopamine isn't acting alone, is it? There are other chemicals involved in this attraction phase, right? It's a real team effort. Remember norepinephrine, same hormone that kicks in during the fight or flight response. Heart racing, alertness, maybe even a little jittery. Sound familiar?
Wait, so that feeling of being head over heels, heart racing, can't think straight kind of love, that's literally a stress response. No wonder those early stages can feel so intense.
You're getting it. And then there's serotonin, or rather, the lack thereof. During this attraction phase, serotonin levels actually tend to dip. And get this, it's the same neurotransmitter that's often lower in people with obsessive-compulsive disorder.
Hold on, are you saying that crazy, can't stop thinking about them infatuation might actually share some similarities with OCD? That's a lot to unpack.
It's definitely a fascinating area of research, and scientists are still piecing it all together. But let's not get ahead of ourselves. We still got one more act to go.
Right. Act 3, attachment. This is where things shift from those initial fireworks to a deeper, more enduring kind of connection, right?
Exactly. Think about those long-term relationships, those close friendships, the strong bonds within families. It's security, comfort, that deep connection that grows over time.
So what hormones are running the show in Act 3? Any guesses?
This is where oxytocin and vasopressin step into the spotlight. They're often nicknamed the cuddle hormone and the monogamy molecule, respectively.
Okay, cuddle hormone. I'm already intrigued.
It's all about those feelings of closeness, trust, bonding. And it's not limited to romantic relationships either. Oxytocin is released in huge amounts during childbirth, breastfeeding activities that strengthen the bond between parents and children. It's like this incredible glue that helps hold all kinds of relationships together.
So we've got lust driven by testosterone and estrogen, attraction fueled by dopamine, norepinephrine, and low serotonin, and finally attachment, where oxytocin and vasopressin take center stage. It's like this perfectly choreographed hormonal dance. But I have to ask, it can't all be sunshine and roses, right? Love has a complicated side, too.
You said it. Even with the best choreography, things don't always go smoothly, do they? And love, well, love is definitely messy sometimes.
Tell me about it. We've got heartache, jealousy, maybe a few decisions we'd rather forget. Why does love have to come with so much drama?
Well, remember those powerful hormones we talked about? Turns out they can have a bit of a dark side. Let's take dopamine, for example. It's all about that reward system, right? But that same pathway, it's also linked to addiction.
Wait a minute, are you saying falling in love is like getting hooked on something?
In a way, yeah. Think about it, that intense longing in the early stages, that feeling of euphoria when you're with your partner, even that almost withdrawal-like feeling when you're apart. Those feelings, they come from those same dopamine pathways that light up in the brains of people struggling with addiction. Pleasure and craving? It's a potent mix.
Wow. Never thought about it that way, but it makes a lot of sense. Love really is playing with fire in our brains.
It can be, that's for sure, especially early on when those dopamine circuits are working overtime. And just like with any powerful substance, too much of a good thing can lead to problems. It's all about finding that healthy balance.
Makes sense. So, dopamine, our little reward seeker, can be a bit of a double-edged sword. What about the other love chemicals? Any chance they can stir up trouble too?
Oh, absolutely. Oxytocin, for example. We called it the cuddle hormone, right? And while it does promote closeness and connection, studies have also linked it to jealousy and possessiveness.
You're kidding. The cuddle hormone can make us act jealous.
I know it sounds strange, but think about it. Oxytocin strengthens the bonds we have with loved ones, which can sometimes make us, well, fiercely protective, even a little territorial. That primal instinct to protect what's ours, even if it means pushing others away.
So it's like love gives us this amazing feeling of connection, but it also hands us this metaphorical shield and sword to protect it. No wonder things get complicated.
Exactly. And remember that whole thing about love making us act a little impulsively? Turns out there's a neurological reason for that, too. When we're smitten, certain areas of our prefrontal cortex, the part of our brain responsible for rational thought, decision-making, they take a bit of a backseat.
Hold on. So that feeling of throwing caution to the wind, making those you only live once decisions, it's not just us being, well, crazy in love. It's our brain chemistry, literally.
Exactly. The allure of those feel-good chemicals, that dopamine surge especially, it can make us more likely to take risks, overlook red flags, all in the pursuit of that love high.
Wow. So love isn't just messing with our hearts, it's actually changing how our brains make decisions. Fascinating. But we can't talk about the science of love without mentioning those prairie voles. I'm ready to hear more about these monogamous rodents and what they can teach us about love.
Ah, yes. Prairie voles, the unsung heroes of love research. They're fascinating because, unlike a lot of other rodent species, they form these incredibly strong pair bonds, much like humans.
So they're like the ultimate ride-or-die couples of the rodent world. What makes them such a good model for studying love, though?
Well, their behavior really mirrors a lot of what we associate with romantic love in humans. They share a nest, raise their young together, and they show this incredible loyalty to their mate. Plus, get this, studies have shown that when a prairie vole couple is separated, they actually show signs of stress and anxiety, almost like humans going through a breakup.
Yeah, okay, I'm sold. These little guys are both adorable and scientifically fascinating. But how does their experience connect back to us, to humans?
Remember those key hormones for attachment, oxytocin and vasopressin. Prairie voles have this really unique distribution of receptors for these hormones in their brains, particularly in areas associated with reward and pleasure.
So are you saying that when they mate and those hormones are released, their brains are basically flooded with those feel-good sensations, making the whole experience more rewarding and strengthening that bond?
That's exactly it. And here's the really interesting part. Researchers discovered that if they blocked those oxytocin or vasopressin receptors in the voles, they were far less likely to form strong pair bonds, like those crucial chemical messengers were being intercepted.
So by studying these cute little creatures and their hormone receptors, we're starting to unravel the mechanisms of attachment, not just in voles, but in humans too. It's amazing what we can learn from these tiny love gurus.
It really is remarkable, and it highlights just how much our brain chemistry influences something as profound as love and attachment.
This has been such a fascinating deep dive so far. I have to admit, though, my brain is working overtime trying to keep up with all these hormones and neurotransmitters. It feels like we've uncovered so much about the science of love, but at the same time, I'm realizing just how much more there is to learn. It really makes you appreciate how complex love really is. But before we go too far down the rabbit hole of hormones and brain regions, I think it's important to remember that love isn't just tea about neurons firing, right?
Absolutely. It's about how those biological processes actually translate into real-life experiences. You know, the moments that make love so powerful.
Exactly, like locking eyes with someone across the room, or that feeling of coming home after a long day and just being present with someone you care about. Those moments are what make it all worthwhile.
It really is about those moments of connection,
Yeah.
sharing a laugh, just understanding each other without even saying a word.
Hmm.
And, you know, diving into the science, understanding the hormones and receptors, it's like we're getting a backstage pass to see how it all works.
And the best part is, the show's far from over. We've got a lot left to learn about love. But for now, maybe we can try to tie it all together. What's the main takeaway you'd want listeners to walk away with today?
I think the biggest thing to remember is that love, with all its ups and downs, is a fundamental part of being human. It's this incredible mix of biology, psychology, and personal experience. All these things come together to create something truly unique.
It's amazing. We have our brains, hormones, memories, all working together to create this one incredible feeling. It's honestly mind-blowing when you stop and think about it.
It really is. And by learning about the science behind it, we can appreciate just how complex love really is. It's not just about finding the one or having some fairy tale romance. It's about understanding what it means to connect with another human being on such a deep level.
That's beautifully said. So the next time anyone listening feels that flutter in their chest or gets that warm feeling when they think of someone special, they can remember. It's not just their heart talking. It's those fascinating pathways in their brain, those hormones doing their thing, creating this amazing symphony of sensations.
Exactly. It's science in action. It reminds us that even the most powerful emotions we feel have roots in our biology. And that, to me, makes love even more extraordinary.
I love that. Well, I think we've covered a lot of ground today. We've talked about the different stages of love, how those key hormones play a role, even those adorable prairie voles, and what they can teach us.
We just scratched the surface, really. Hopefully, we've sparked some curiosity and got everyone thinking about how love shows up in their own lives.
I think that's a good goal to have. This deep dive has definitely given me a lot to think about, and I have a feeling this is one of those topics we'll revisit as we learn more.
For sure. Love research is always evolving. Who knows what we'll discover next? But in the meantime, just remember, next time your heart skips a beat, it's really your neurons firing, your hormones putting on a show. Science, yes, but with a little bit of magic sprinkled in.
I love that.
Oh.
And on that note, we're wrapping up this deep dive into the fascinating world of love and the brain. Until next time, everyone, keep those neurons firing and remember, love really is all around us.